Professor Kimball. For our project, we made a GPS tracker that connects to cellular towers, so you can send your GPS location not only through Wi-Fi, but through the cell network, unlike tiles. We got the inspiration from this for this project after looking at tiles, the little trackers that you attach to your keychain, and realizing they had one major problem. They rely on other people's phones to relay your location. So we wanted to rectify this situation. That is why we set out and designed our own PCB so it would hopefully be keychain sized. This is the size of the PCB. It's relatively small for what we did, and I'm sure we could get it smaller if needed. Alejandro has the working PCB, so I'll turn it over to him.
I have the working PCB here right now. It's this one over here. So it's the only one that works right now. We had some problems with different components and traces that were in the wrong place. So we had to reorder everything again, and that's why we couldn't finish this 100%. I also have another one here that doesn't have all those wires attached. And this way you can see how it was supposed to be. So you have the USB ports over here, where you can program the ESP or upgrade the firmware of the GPS module. And you also have the SIM card over here, and you can put two batteries here. Right now for these tests, we have the battery outside, so we can attach a voltmeter and measure how much current is flowing into the module. So the module is right now is sleeping. So as you can see, it's not drawing any power. It's 0.5 milliamps-ish. But whenever it detects some kind of movement, or you press one of the two buttons, these ones over here, 1 and 2, and it will wake up and start relaying your position to a server. So I just moved it, so it's now relaying its position, and it will go back to sleep again. So you can wake it up by movement, or you can use one of the two buttons and you can interact with it. So this is a very simple example where with interrupts, I'm able to press these buttons and change what's on the screen. So these are different pages of a menu or whatever. It will also wake up each 15 minutes to relay its position, even if you haven't moved it or anything like that. This is a picture we've taken of our PCB. And here we have the main LTE antenna that we use to connect to the mobile networks. And this is our small patch antenna that we use for GPS receiving. So this antenna is a passive one that doesn't require any power, but this one does. And we are also switching the power that this antenna gets on or off, depending on if we are doing some kind of GPS work or not, to save even more power. This is our main microcontroller. It's called an ESP32, and it performs mostly all the tasks. This is both the GPS receiving our LTE module that we are using. It's based on one of the latest Qualcomm designs, so it has these new LTE low power bands that we can use to be in a very low power state and still be able to receive things from the outside. So we also have here a very small battery charging IC, which is in charge of charging the batteries, which are on the bottom, while connected through USB. And it also interrupts to the ESP when something happens, like the charging starts or ends or something like that. We also have some battery protection ICs over here that will cut the battery power if the voltage gets too low or too high. And finally, we have the USB to UART converter here, and we debug and program our ESP through this one. And finally, below this cable, we have two small sensors, an IMU and and altimeter, and we just use them for several. So we have our schematic divided in 4 sheets. You will be able to access the schematic in the, and you will find a link in the report. There are like 4 different sheets. One of them is for power management. The other one is for the SIM module and some MOSFETs and so on. And this one is for the microcontroller, USB, and this final one is for some extra stuff like the IMU and the altimeter. So once the microcontroller wants to send its location to the server, it will communicate to our web page through some HTTP requests that we've set up. So it will tell the server its new location, and the server will store them in a database. This server can run both in a Raspberry Pi or in just like any kind of computer. So once you're in this web page over here, you have all your devices here. So each device has its own ID and security token. So only if you're the owner of the device, you can post like new location data. So you can click here through your different devices, and it will show where like the last, I think, 5 points, 5 locations that the device reported. And you can click each one and see more detailed data like the altitude, temperature, how much battery was left, like that with all the devices. So this is a small problem we had, like is that the GPS accuracy is not high enough for this. So this should be the same point, but they are like slightly far apart. And you can also switch accounts, and you can see like for example, like William's account has 1 device and his routes over here. For power budget, so this was the first thing we created. So here we have how much current each thing will consume during sleep, and here is how much current each thing will consume while working. So each item has its how much current and for like how long they run. With all that and with the wake up interval, we can calculate how long the batteries will last. In this case, with these settings, which are a little bit worst case, we are doing around 200 something days. Based on the values I got from my voltmeter, we can probably be talking around 250 to 300 days in like one charge. And you can recharge the battery in like 2 to 3 hours. So even though we are using an Arduino compatible chip that you can program with the Arduino IDE, we are using Visual Studio Micro because we also had to develop for the ultra low power processor. So most of our code is in the usual Arduino-ish C, which is both in this main file and in different classes. Some of them, for example, for the screen or the IMU. Then we also have the ultra low power processor, which is this one. So you have to write code for this in assembly. It's not very long, but it was pretty hard to get this working, because you have to embed this code within a part of the C code, and then you move the code to a specific region of the memory to get it to run. Where we are using, it's coded on C#, and it's based on ASP.NET, and it handles everything from the data intake to finally like rendering and showing the data in the web page, which is this one. So in order to like send data back and forth, we are using some HTTP requests like this one, which asks for the last 10 points, for example, of this device, or this one, which is the one that is run from the Arduino. This one just like takes device ID and then some like parameters that you want to store, like altitude, battery level, and then the coordinates, and it pushes all this data into the server. And then you can instantly see all that data up to date here. Here on the left side, you can also see like some labels like lost or live or okay or warning. That depends on the device. For example, lost means that it hasn't received any updates in the last 2 hours. And then if it goes live again, it will say here live.